Greetings. You know, one of the most common use cases in the IoT world is collecting sensor data from a very large number of devices and figuring out which of those gazillions of devices need attention first. And if you're really good, you go give those the devices the attention they need before things go really, really wrong. And that's exactly what we're going to talk about today. My name's Calvin Powers. I'm your host here on IBM Developer Tech Talks, and our guest today is Sharath Kumar. He is a data scientist at IBM Software Labs in India. He specializes in data mining, machine learning, artificial intelligence, deep learning, cloud computing, all that stuff. So he's a perfect guy to talk to us about this topic today. Sharath, welcome to IBM Developer Tech Talks. Sharath,
Thank you, Kelvin. Thank you, Kelvin.
So before I let Sharath do his presentation, I need to do a little bit of house cleaning, or housekeeping, I should say. If you are watching this video on YouTube, there is a chat window beside the player, and if you have any questions for Sharath, you can ask them in that chat. I will be monitoring the chat, and I will route your questions to Sharath at the appropriate time. Also, I want to call your attention to the description field below the player, and the very first link in that description field is a link to today's event page. That event page will have all the getting started links, as well as links to some of our other newsletters and getting started information that you might be interested in. So do yourself a favor and visit the event page at some point, either during or after you watch today's presentation. And lastly, I want to note, if you're already watching us on the event page, the YouTube chat is at the bottom of the page. So if you're watching on the event page and you have a question for Sharath, scroll to the bottom of the page and you'll see the chat there, and you can post your questions there. All righty, let's get into it. Sharath, what do you have for us today?
Thanks, Kelvin. So today's tech talk would be on predicting equipment failure using IoT sensor data. I'll just share my screen as well.
No, you're not sharing yet. Try again. To share your screen, hover your mouse over the left side and click the green box with the white arrow.
Yes, I have done that. Are you able to
there
see
it goes. Now I see it. You're good.
Yes. Perfect.
It's just a small delay. Okay, go for it.
Okay, so today's tech talk is about predicting equipment failure using IoT sensor data. So in this session, we'll be doing the detailed walkthrough of the code pattern, which is to predict equipment failure using IoT sensor data. Before we dive into this code pattern, let's understand what exactly is a code pattern. Code pattern is about delivering the solution for a specific problem. We pick the industry-wise use cases, and then we try to solve it using IBM technologies. And then we open source that solution so that developers worldwide can access it, fork it, and then enhance it to suit their requirements. As you can see here, it provides a 360-degree view of the underlying code, architecture diagram, etc. And it can also be called as a roadmap for solving complex coding challenges. With that being said about code patterns, let's dive into this code pattern, which is about predicting equipment failure using IoT sensor data. So when you click on that URL, this is the page you will land into, where you'll see two options. One is get the code, and second is view the demo. We'll select the get the code option, where we are taken to the GitHub repository for this IoT predictive analytics. Internet of Things can be classified into three types. The first type would be the devices which are collecting the information from sensors and then sending it. The second type would be receiving that information and then trying to process that information. And the third type would be doing both. So in today's tech talk, we'll be focusing more on the second part, which is that we have received the information from the sensors, and what do we do with that information? How do we make smart decisions, and how do we generate some predictions which will help in maximizing the manufacturing efficiency of a particular equipment. So in this code pattern, we can see that it is intended for anyone and everyone who wants to experiment a new method of predicting equipment failure using IoT sensor data. And we can also see that in order to identify that a change is happening, there is another code pattern which refers to change point detection IPM pattern. That is a different pattern which is on this page, which will talk about the values coming in the form of time series data, and whether a change is happening in that particular variable. And if that change is happening, what do we do with that change is what we'll be covering in this code pattern. So this pattern is intended for an end-to-end walkthrough of generating a prediction methodology, which will use IBM services. And after the completion of this tech talk, the user will be able to understand how to read IoT sensor data, how do we configure the features and target variables, and how do we do the train and test split, and how do we evaluate the model performance and rerun the experiments by changing the parameters. We can now look at the architecture diagram. So if a user is wanting to know whether there will be a failure of a particular equipment or not, what does he do using the IBM services? How can he find out, by generating the predictions and enable him to take smarter decisions? So in other words, what we are trying to do here is to replace preventive maintenance, which is trying to do the maintenance of an equipment before it breaks, with the predictive maintenance, which means we will be doing the maintenance only when it is needed, thereby saving costs, and we will also help in not keeping the machine idle just because of maintenance. So the other components which are part of architecture diagram are IBM DB2 warehouse. This is where the data which we have received from the sensors is being stored, and we have Watson Studio platform, which will give us an opportunity or a platform to host different machine learning experiments or deep learning experiments depending on the requirement. And we also have object storage, which will help us store the data, the configuration files, so on and so forth. And all this processing is done by the Spark engine, which will propel the Watson Studio platform to run the experiments. We can just look at the steps where we need to sign in for IBM Data Science Experience, which is now called as Watson Studio. We are expected to load the sample IoT sensor time series data to the database. I will show the sample data, how it is. So this is the sample data that we have selected for this code pattern. The reason why we have not done the first step, that is to capture the data from different devices, is because we do not have access to the different data sets coming from different devices, and that is the reason we have not touched that part. But I will show it to you what are the IBM services that we can use to capture the data which is coming from multiple sources.
Hey, Sharth, this is Calvin. I think you just answered this question, but a question came in saying, can you run this pattern without having real IoT devices? So that spreadsheet of data is used to represent the data that would come in from the devices. So the whole code pattern can be run without actually having hardware IoT devices, correct?
Yes, that's correct, Kelvin.
Terrific.
So this is assuming that we have already received the data. But if there is a requirement that we have to collect the data from multiple devices, we have a different platform, that is IBM Internet of Things platform, which will enable us to capture the data from different devices. Let me quickly go through that platform. This is the platform that we have from IBM, which is about Internet of Things. And you can see that under features, it can quickly and securely register and connect the devices. It can analyze in real time. There is also information management, which can control the flow of the data, and there is also risk and security management. And if you see the plan, there is a free plan as well, which will include signing up to about 500 registered devices and a maximum of 200 MB of each data metric. So this is not explored because of the lack of data coming from different devices. And if we need to get started, we have the docs as well. And if we open the documentation, we will get step-by-step instructions as to how to get started using the Watson IoT platform.
And if I can just jump in again, Sharath, folks, if you go to the event page, you'll have a link for signing up to get a free IBM Cloud Lite account. And as you can see, Sharath just mentioned, on that free IBM Cloud Lite account, you're able to actually use the IoT platform and services enough to do your development and testing and whatnot. So do yourself a favor and go sign up for an IBM Cloud Lite account over at the event page. All right, end of commercial. Back to you, Sharath.
Okay, so this is the data that we are trying to do multivariate analysis, where the columns A to I would be the variables, which are the predictor variables, and we are trying to predict the column J, where we are trying to determine whether an equipment will fail or not, given the parameters from A to I, where 1 would indicate a failure and 0 would indicate a non-failure. So this would be a classic example of a binary classification problem. And we will go back to the site where we can see how well we will be able to use IBM resources to solve that problem. So in this code pattern, we can see that the components which are included are IBM Watson Studio, which is predominantly used for analyzing data using Python, Jupyter Notebook, and RStudio. Python and R are the programming languages which are supported on Watson Studio, which is in a collaborative environment that also includes other IBM services, which can be uh, included in that. And we are also using DB2 warehouse on cloud. This is predominantly for doing edge analytics. If you have real-time data coming in, then you need a place or you need a database to store the data. This is where we can use IBM DB2, which is on cloud, and it is a fully managed cloud data warehouse. And we are also having IBM Cloud Object Storage. This is an internal storage which comes within IBM Cloud Platform, where we can save the data which is coming from DB2 and then use that for processing in the Watson Studio platform. We'll see more about this in the Python notebook, which has been designed to integrate all the three components. As you can see, the feature technologies in this code patterns is only limited to analytics and data science, because the Internet of Things is in a different module, and that has to be configured, and then instance has to be created, and it is assumed that those things have been done, and we have received the data from the device, and we are proceeding forward. We also have a video which will give you, a brief introduction of what is there in this code pattern and how do we access the services in brief. And then moving to the steps. Kelvin, do we have any questions at this point?
No questions at this time, Sharath.
Okay. So let's look at the steps as to what are the steps that needs to be taken to achieve this, to create the predictive model for predicting the equipment failure. The first step would be to sign up for Watson Studio. It is now called as Watson Studio. It was called as Data Science Experience earlier. But if you log into this URL, the instructions which are given here would still work. Only the name has changed. So it talks about signing up for Watson Studio, and then the two services, Spark and Object Storage, will be created in the IBM account. Once you sign up for IBM Cloud, you will get a free 30-day trial account. You can use that, and then you can access all the other services which are available under IBM Cloud. So when we talk about Watson Studio, I want to give a little more about what Watson Studio can do. It is a platform for doing all kind of data analysis, which is possible. It can be structured data, it can be unstructured data, it can be images. As you can see the screen, there is a data science project which can be created, or a standard project, or a visual recognition. We also have a deep learning project as well, uh, where our Watson Studio platform will support deep learning frameworks like TensorFlow, Caffe, and Keras. And we have modeler project where we can train SPSS models on the cloud and then deploy it for real-time scoring. We also have business analytics, which is predominantly for visual analytics using IBM Cognos, where we can create powerful dashboards and then link it to Watson Studio. We can do some data engineering work as well, where this is more of data pre-processing before it is consumed by other smart algorithms and services. We also have services which is for streaming data as well. So in order to do the first part of capturing the data and sending it across, we can do the streaming analytics clubbed with the Watson IoT platform, and those two will do the job to capture the data from different devices and sends it across. And then we can get started with this code pattern to to mine the data and to generate insights and determine or derive some predictions out of it. So that was a brief about what Watson Studio can do for us here. Moving into the second step, we have to create IBM Cloud Services. This sample data is the same as what I had shared earlier. It has about 1,000 rows and some 10 columns, and that is what we are trying to do the prediction of that equipment failure. And we are expected to create a DB2 warehouse instance on cloud. This is to manage the dataset. Either we can upload the data manually, or we can have real-time data streaming onto the table in the warehouse. So this instructions is given here as to how to create a connection to the database and how do we load and access the data in the notebook onto this database. So this DB2 is needed if we are talking about real-time data, and if we are uploading the data manually, then we can use the IBM Cloud Object Storage in Watson Studio platform to load the data and then do all the data mining and predictive activities on that particular data. So it talks about the instructions. We are continuing with the instructions on how to set up IBM Cloud Dashboard, and it talks about how to browse and upload the file onto the DB2 instance. We'll also talk about creating a schema, table, so on and so forth. The name of our dataset is IoT sensor data. So after the data is loaded into the DB2 warehouse, we'll have to create the connection in Watson Studio so that we can access the data from the warehouse. This is what is happening in this step here. In Watson Studio, after we create the project, we have to select the data services, and then we have to follow the instructions to create the connection, and then select the service instance name, which we had created in the previous step. And then we are good with establishing the connection in Watson Studio. The next step would be to create the Jupyter notebook. So when we have the data coming from the sensors, we need some processing to be done on the data. In this case, we have done all the processing for you. All you need to do is follow the instructions here and take the notebook which has been mentioned here and run it on your particular data set, and you should be able to get the results of the prediction that we are trying to achieve here. So the instructions is telling us how do we select the notebook and how do we upload it onto the Watson Studio platform. We can have a quick look at the notebook. So this notebook is done using Python programming language. So we are importing a couple of libraries, and we are creating some generic functions for analytics. And then we are doing some configuration here using the config files, which are already uploaded in the object storage. And it also talks about how do we manage the data which is coming from the DB2 and also from the object storage. It's talking about the param.
Sharth, sorry to interrupt.
Yes.
There's a question about how somebody instantiates this notebook. If they're following along the code pattern, will they be making a copy of this notebook for themselves, or how do they create the actual notebook?
Yes, they will be making a copy of this notebook.
Okay.
So the notebook is uploaded onto this GitHub repository.
Uh-huh.
If they select the from URL tab, and then if they give this URL there in their Watson Studio instance, the notebook will automatically get created there, the same notebook.
Okay. All right. And it'll have a unique URL at that point.
The URL will be the same.
Oh, okay.
So their Watson Studio instance will be different, right? So their credentials will be different.
Oh, I see.
If you look at the credentials here, these credentials, object storage credentials, this will be different for them. They will have the end user will have their own credentials.
Okay.
This has been given here only for illustration purpose. This is how it will look if you upload the notebook on your Watson Studio instance. Rest all the features will remain the same.
Okay, thank you.
So here we are reading the sensor data from the database where we had uploaded earlier. It talks about the number of observations and what are the columns which are available in the data set, and then it also talks about the how do we split the data. We are splitting it with the 70-30 mix. 70% is being used for training and 30% is being used for testing. That is a standard split that is followed in most of the data science use cases. And then we have arrived at the confusion matrix. This is one of the metrics which is used for binary classification. And then we see that our sensitivity score is about close to 94%. Sensitivity is about identifying true positives. That means in a given data set, how many rows or how many data points are leading to tell us when the equipment is going to be a failure. So we are more concerned about identifying the failures rather than identifying the non-failures, right? So in this case, we are able to achieve about 94%, even though it's a sample data set. So that is 9.4 times out of 10, we are able to predict correctly that there will be a failure in the equipment given the parameters from other variables. So we can use this to predict on the new data as well. We can use this model, the trained model, and then we can feed the new data points, and it will tell us whether there will be a failure or success with an accuracy of 94%. That is how we should infer these results. Any questions here, Kelvin?
So can you speak just briefly on how you could deploy this model for scoring new data? And then there was another question that came in that said, can you tell us any details about the devices that generated the sample data for this project?
So the data has come from an equipment sensor of only one equipment. I mean, there were not multiple equipments. The data was coming only from one equipment, and the data has been masked as well because we could not share the actual data due to NDA. So
Sure.
the data has been masked to give a sample of how the data would look from the when it is coming from a
Okay.
IoT device.
Fair enough. Okay, so we've had to scrub the device information so that we can stay protected under NDA. So sorry about that. And then the other question was, I don't know if you've gotten to it at this point in the code walkthrough, but there's a question about how you would deploy this and score new data with the model now that you've got it trained.
So after the model is trained, right, if you look at the steps 5.2 and 5.3, it is talking about scoring the test data.
Okay.
So we can use this section as to what it is written here, and we can give new set of data points. Say for example, we just need to give this 9 data points, and we can use that parameter, and it will tell us whether there will be a failure or non-failure of that equipment. That is
Mhm.
how you do the scoring. Did I answer your question?
I think so, yes. Thank you.
Welcome. So in this binary classification, the technique that has been used is logistic regression. But for this kind of problem, we can use other techniques as well, like decision trees, random forests, extreme gradient boosting. We can even use deep learning techniques if there are more number of data points coming from multiple devices. Then the standard machine learning techniques might not work that well. That's when deep learning comes into play, and deep learning works or provides better results with more data. The more the data, the better the results would be from the deep learning technique. And we have Watson Studio platform to hoist different deep learning frameworks which are there. So
So,
this is just.
Sharth,
Mhm.
I'm a newbie to the world of machine learning, so let me just ask the dumb question. So what I think you're saying is using this existing model, if its predictive capability starts going low, like you said, now it's at 94%, but
Mhm.
over time, if we discover that that predictive ability is going low, you might switch and use a different model out of the Watson Studio that has a better chance at doing the predictions correctly.
That's correct.
Okay.
That's correct. We have different models hosted in Watson machine learning service, which can yield in better results as well. And like I said, the difference between machine learning and deep learning would be with the size of the data. The more the data, the better will be the results from the deep learning methodology. However, to run deep learning models, you need more computational power as well. You can't run them with regular CPUs. You will have to go for GPUs like NVIDIA GPUs. So that is the downsides of that is a disadvantage of deep learning, you can
Okay.
say.
So you start out using these lighter weight models because they're computationally less expensive.
Yes,
And then you move to the more expensive models only when the lighter weight models are failing to do their predictions.
that's correct. That's correct. That
Okay.
is simply put. That is in the better way. So after we are done with importing the notebook in the Watson Studio environment, we'll have to import the config files as well, which will tell us about what are the features which are being considered to make the predictions. Are we using all the 9 features, or are we just using 3 features or 5 features? That is what will be described in the configuration file. So it again depends from data set to data set. If it is an iterative process. For example, if you use all 9 features and your accuracy is around 85%, then you might want to reduce 1 or 2 variables which are non-significant, and there could be a spike in accuracy. So that's how you'll have to iteratively decide what are the significant factors which are influencing the outcome. So that's how you build a statistical model, which will yield high accuracy. And high accuracy is needed because if you provide new data which is not seen by the model, then the predictions has to be accurate. That is the reason it has to be trained well with significant variables so that it can do well on all the other data sets. That is, the generalization should be harnessed well with the model. So the config file is telling us the features, and it is also trying to tell us what are we targeting. We are trying to target the failures, and it is also telling us what is the split of the data site between the training and testing. It is 70-30. So that's what it is telling us here in all the 3 points. And then after reading the configuration file, we are seeing more instructions as to how do we manage the credentials here. That's what, like I mentioned before, the credentials will come from different users. Different users will have different credentials. The same will have to be updated in the notebook before we run the notebook. So all this information is already given in the notebook. It has been updated in the documentation as well for better understanding. And we are adding the data into the notebook, and we are reading the IoT sensor data from database, which is also there in the notebook. And then once all the steps are complete, the first 4 steps are complete, we are running the notebook. And then we are checking the results to identify what would be the training accuracy and whether there is any underfitting or overfitting, so on and so forth. Overfitting is when uh, the model performs really well on the training data, but when you feed the new data, then the model performance drops drastically. And underfitting happens when the model does not perform well even on the training data as well. That's when you'll have to come up with new variables, and then you'll have to derive new variables and then try to see if that can give a lift in the accuracy. Any questions so far, Kelvin?
Yeah, there are some questions, and again, I think I for one, am a very new person to machine learning, so forgive the basic questions. The sample data that you have, how does the sample data indicate to you which rows, which combinations of variables are failures already? Or tell us a little bit more about what's involved in training. So how does the model know which from the sample data, the training data, how does the model know which are the data items that have generated a failure and which haven't?
So that will be done by the model at the back end, Kelvin. So you're talking about the significant variables out of this 7, which are having a major impact or a significant impact on the outcome. That will be decided by the model, whether it will be the first variable or third variable or fifth variable or a combination of these 3, which is influencing the outcome.
Right. So column J is a prediction from the model. Is that correct?
Column J is what we are trying to predict using column A to I variables.
Oh, I see. So column J indicates this row was a failure if it's a 1, and and if it's a 0, then that was a success. That was not a failure. And so you're trying to get a model that will predict the exact same combinations of 1s and 0s.
Exactly. That's exactly what we are trying to do. And like we discussed, we can start with lighter techniques and then see how the accuracy is coming. If the accuracy is low, then we can go for far more advanced techniques, and then we have the platform to make use of. And then we can include other deep learning techniques as well to enhance accuracy at the cost of computation.
Terrific. Okay, thank you.
Welcome.
That's all the questions we have right now.
Okay, I think we have almost come towards the end of this of this code pattern.
Okay.
It talks about the results and so on and so forth. And I would also like to take the audience through the important URLs which needs to be bookmarked. The first one would be to sign up to IBM Cloud, that is console.bluemix.net. And if we want to view the catalog of IBM Cloud Services, it is console.bluemix.net/catalog. And if we want to view the documentation of cloud services, it is console.bluemix.net/docs/home and /all docs. And there are also software development kits available. For example, we have IBM services, right? IBM APIs. How do we invoke the IBM APIs? And these are the services, these are the software development kits which are available to invoke IBM APIs. It starts with Android, and we have Java, we have Node.js, Python, Ruby, and Swift, and Unity, so on and so forth. These are the software development kits which are available, which can be used to invoke the IBM APIs.
Okay, Shara, thank you very much. With your permission, I will put that presentation on the event page, if you can email that to me. So
Sure.
That way people can have all of the links.
Absolutely. And before we sign off, I wanted to highlight the last three URLs. One is developer.ibm.com/code/patterns. In this page, you get to see code patterns which are developed for different technology tracks. We have more than 200 plus code patterns which are available and open sourced. Developers can use them free of cost, and the source code is also given in the code patterns. And we have two demos as well, Watson Studio demo and Watson IoT platform demo, which will be helpful in developing a end-to-end IoT solution.
Terrific. Thank you.
Welcome.
So once again, folks, if you're watching on YouTube, the first link in the description will take you to the event page. On the event page, you will get the link to the code pattern so that you can follow along the steps that Sharath showed us today. And I don't have the presentation on there yet, but I hope to within the hour. So if you're watching live, check back that page in an hour, and I should have that presentation file up there so you can get all of the links that were talked about today. And so it should be plenty of information for you to get a free IBM Cloud Lite account and get started in building your models by following the instructions in the code pattern. And then once you've sort of familiarized yourself with all the steps in terms of setting up your databases and your models and whatnot, you can start experimenting from there and building your own models against your own data sets. So do yourself a favor, visit the event page, get yourself a free IBM Cloud Lite account, and visit the code pattern page. With that, I think we're done. We have no more questions. Shara, thanks again for giving us your time today. I know it's difficult for you to present at this time of day.
No problem. Thanks a lot. It was a pleasure being here.
All right, bye-bye.
Thank you.
And thanks
Bye-bye.
everybody for joining us.
Thank you, everyone.